Junior Roberts here. Number one question I'm asked is how it is that we work questions in physics. So in this video, I want to just outline 7 steps that we take when it comes on to working questions in physics. So the first thing we do is obviously we want to read the question, right? And we want to ensure that we're reading the question clearly and thoroughly. So this question here says, a popular waterfall is 210 meters high. The temperature of the water at the top of the falls is 20 degrees Celsius. The temperature of the water at the bottom of the falls is 20.5 degrees Celsius. And we want to calculate the specific heat capacity of the water. And that actually leads us into step 2, to ensure that we get as much information from the question as possible. So in this question right here, we're given the height of the waterfalls. Right, we're given that the temperature at the top of the falls is 20 degrees Celsius and the temperature at the bottom of the falls is 20.5 degrees Celsius, and we're asked to calculate the specific heat capacity of the water. And once we have done that now, we make a simple sketch to just illustrate the scenario. So we have our sketch right here. So this is our waterfall. This is the height of the waterfall, which is 210 meters. Temperature at the top is 20 degrees Celsius and the temperature at the bottom is 20.5 degrees Celsius. Alright, so once we have made a sketch of the scenario now and we have all the information from the question, we can now either make a statement based on the scenario, right? Or we can write an equation. In this scenario right here, we're going to have the water at the top of the waterfall falling down to the bottom of the waterfall. Now, during that descent, we're going to have energy being converted. So we're going to have energy at this point being converted to the energy that will exist at the bottom of the waterfall. Now the energy at this point, which is at the top of the waterfall, will be in the form of gravitational potential energy. So that gravitational potential energy will be converted to kinetic energy at the bottom of the waterfall. Now that kinetic energy will cause the temperature of the waterfall to increase. So the first thing we can consider is we can consider a statement that we're going to say, okay, we're going to have gravitational potential energy will be converted to kinetic energy. So we can see that the gravitational potential energy will be equal to the kinetic energy at the bottom of the waterfall. Now, the kinetic energy, as we said before, will cause the temperature of the water to rise. So then, that increase in temperature, right, we can actually write an equation for that, because remember, the energy supplied, right, is equal to the mass of the substance multiplied by its specific heat capacity multiplied by its increase or its change in temperature. So we're going to have E is equal to mc delta T. Now again, the gravitational potential energy was converted to kinetic energy, and that causes the temperature to rise. So we can further take this a step further. So initially, we have gravitational potential energy being converted to kinetic energy, which will cause the temperature to rise. So we can write then know that the gravitational potential energy we know from before is mgh, right? That energy will be equal to mc times the change in temperature, which is the heat energy required to raise the temperature of the water. Now, if we look closely, we have the mass on both sides, so we can cancel the masses. So then, we're going to have GH is equal to C times the change in temperature. Now, in this question, we were given let's just write some values that was given. So we're given the height, which is 210 meters. We were given the temperature at the top, which is 20 degrees Celsius, and the temperature at the bottom, which is 20.5 degrees Celsius. So we can find that our change in temperature, delta T, then now, will simply be equal to 20.5 degrees Celsius minus 20 degrees Celsius, which works out to be 0.5 degrees Celsius. So that's our change in temperature. Now also, we know that G is always 10 meters per second squared. right? And we're trying to find C, which is the specific heat capacity, so that's our unknown. So now, what we can do now is we can actually rearrange our formula to make C the subject. So if we divide this one by delta T, we divide this one by delta T, we're going to see that C will be equal to GH divided by delta T. Now just rewriting this so that we have C on the left hand side, we can say C is equal to GH divided by delta T. And once you have done that now, what you will do now is you will now substitute. So step 5, you're going to substitute your values into the equation. Now substituting, G is 10 meters per second squared, so we have 10 meters per second squared multiplied by H, which is 210 meters, divided by the change in temperature, which is 0.5, so 0.5 degrees Celsius. And then in step 6 now, you will simplify. We will say 10 times 210 works out to be 2,100, and we divide that by 0.5. Step 7, you will just solve using a calculator and express your answers with the appropriate unit. Now, once we divide these two, so we say 2,100 divided by 0.5, we get that C is equal to 4,200. Now our unit right here will be the joule per kilogram per Kelvin. Alright? Those are the 7 steps that we use when we're solving any question in physics. So first, we read the question, extract the information from the question, sketch a diagram, right, based on the question and the scenario. Then we're going to write an equation or make a statement. Then we're going to substitute, solve, simplify and solve, and then we express our answer in the appropriate unit.